After studying several problems of the day that involve real-world situations and looking at the meaning of slope as change, rate of change, and then bringing it down to the change in y over the ratio of the change in y over change in x, today we played further with just plugging equations into a graphing calculator to see what controlled the outcome of those graphs. All of these things together led to our discussion of what is known as the slope-intercept form of the equation. We saw from our own experiments today that when an equation is solved for y equals something times x plus a constant, we could see that this number told us where it crossed the y-axis. Otherwise known from this point on as the y-intercept. Intercept sounds like intersect, and that is really what it means. And in our real-world situations, if you recall, it was the starting point. And when we actually graph these equations, it will be our starting point. The number that multiplies x tells us about the rate of change. In other words, the slope. How much each unit is getting multiplied by. And from here on in, that will be called the slope. In all textbooks, they use the letters M and B. This one is pretty clear where it crosses the y-axis, and remember, it has to be that. What we found out about slope is the bigger the number that it's getting multiplied by, the steeper, and the smaller, the less steep, as well as positive slope looks like that, negative slope looks like that. So we're putting all these things together and looking at how to solve equations, how to graph equations, using the slope-intercept form of the equation. It's quite a handy-dandy little tool. What I do now is use my little camera roll and get my graph and talk about the steps for this. I wish I could move that over. Oh well. Let's say my equation is y equals 2x plus 3. What I always want to do, I know that this is the y-intercept, and therefore it tells me that that's a point on the line. So the first thing I want to do is graph the y-intercept. I'm gonna stop at that because I think you understand. The y-intercept, not the x-intercept, it's where the line crosses the y-axis, and since that is a positive 3, I'm going to go up 3 and plot my point. Starting there, and this is important because that's the point on the line, that's how we know where we are. From there, and remember we called it the starting point, use the slope, which we have in the past called the rate of change, to graph two other points. I'm just saying 2 arbitrarily. Okay, and so we know that slope is rise over run, and so if the slope is 2, that means the rise is 2 for every unit. It's going up, it's doubling, it's being multiplied twice for every one that it goes across. So I'm going to go up 2 over 1, up 2 over 1. Of course, on a graph, if I run out of room, up 2 over 1 is the same as down 2 to the left 1. And I also want to use my common sense and say, okay, does this line look like what the lines are supposed to look like? Is it positive? Does it seem about the right steepness? Now, this particular thing does not let me use a straight edge too much, so I'm doing my best here to draw a straight line, and there is my graph. So you're going to use this to graph the y-intercept, and from there to use the slope to graph 2 points. I do want to tell you that the slope-intercept form is by definition, I'm going to go sideways, y equals mx plus b. So you have to first make sure that is solved for y. Otherwise, none of this really makes sense. So let's do one where that's not. In the next one, oh no, I've got to import my thing again. Camera rule. Okay, so in this one, I'm going to say 2x plus 3y equals 9. I'm going to start over here. This is really not a good use of this space. And I should play with moving it, but I don't know how to do that. So if I say 2x plus 3y equals 9, remember we want to isolate y on one side of the equation. So the first thing we're going to do is subtract 2x. And that gives me, and pardon me for moving the equal sign over, but that's how we'll fit. 3y equals negative 2x plus 9. And remember, we want to make sure that it's in slope-intercept form. That's why I told you from the beginning to try to get in the habit of putting the term with x before the constant. Now I need to further isolate y, so I'm going to divide the whole thing by 3. And that gives me y is equal to, and if you recall, that's how we get the slope, negative 2/3 x, and then plus 3. So now I'm ready to use this to graph. So the first thing I want to do is graph the y-intercept. Oh, look at that. It starts at 3 again. From there, I'm going to use the slope ratio, rise over run, to find other points. Well, technically, rise is really a drop, so I'm going to go down 2 and to the right 3. And since well, I guess I'm not really out of room. Down 2 to the right 3. I could also go up 2 and to the left 3. And there's my line. So some of your homework is as easy as just looking. Sorry. Okay, that's how well a straight edge worked for me. Oh well, you get the idea. Sorry. Some of your homework is as easy as saying, what's the slope of the line y equals 1/2 x? Well, it's always the number that multiplies x. So you have to name the slope and the y-intercept and a whole bunch of things. But the most critical skill tonight is to be able to graph lines using the slope-intercept form of the equation.